Okay, we will start with the easy question first. So for 6A, right, the question is asking you for an experimental method in which you can actually follow how the rate of the reaction progresses. So by now you should know that there are two methods of data collection. One of them is called the initial rate method. The other one is called the continuous method for data collection. In order to make things simple, let's just consider continuous method. So for continuous method, how many experiments will you be doing? One only. Alright? So basically it must be something that will change as the reaction progresses, that allows you to measure how the rate of the reaction changes as the reaction progresses. Okay, so looking at the way the question is phrased, right, can you tell me what is something that will change as the reaction progresses? So color, what you can actually measure is the color intensity. So you can measure the change in color intensity as the reaction progresses. What about if you look at the overall equation? What is something else that will change as the reaction progresses? Sorry? No, something you can measure. Yes, OH minus will change, but what does it affect? pH. So you can measure the change in pH as the reaction progresses as well. And finally, if you look at the number of ions on the left-hand side and on the right-hand side, do they have the same total number of ions or different? Different, which means that the electrical conductivity will also change as the reaction progresses. So you can also measure that to monitor the rate of reaction. So basically for kinetics experiment, right, we always choose something that is easy for us to measure to follow the rate of reaction. Okay, so in this case, we can actually do one of the three following. So take note that these three are all the continuous method, but if you want to use the initial rate method, that's perfectly fine as well. Just that it's harder to write for initial rate because you need to do more than one experiment. One more minute to move on. Copy very slowly, then just take a picture and slowly copy it. Okay, let's move on. I can't be waiting for you forever to just copy these three following points. So the rate equation will look like this for this question because by now you should know that rate equation is always written in terms of reactants. And over here you can see that there are 4 different reactants. What I want you to do now is look at B part 1. Tell me for B part 1, you are trying to find the order with respect to what? Just asking you to read the question. I'm not asking you a difficult question. I'm asking you for B part 1. You are trying to find the order with respect to what? Then B part 3, you are B part 2. You are trying to find the order with respect to? So interestingly, in this question, they never ask you to find the order with respect to water and OH minus, even though those are reactants as well. So now I'm telling you, if the question never mentioned anything about the other reactants, you need to assume that they are going to be kept constant during the course of the entire reaction. So you don't need to be bothered about that. So in other words, for this question, right, I can rewrite the rate equation to be like this. Okay, where these two will be kept constant during the entire question. This is something that you need to know. When the question don't mention anything about the other reactants, always assume that they are kept constant. Okay, for that entire question. And that's why you don't need to be concerned about that. Okay, now comes the important part. If you remember previously, I mentioned to you that this question is a combination of continuous method as well as initial rate method. Okay, I want you to follow my train of thought very carefully. Do not copy anything while I'm talking. So first of all, if you want to find the order with respect to AS2O3, this means that what must change between these two? This one must. I want to find the order with respect to this one. Which one of these two must change? This one must remain constant. So can you tell me if I want this one to change, but I want this one to remain constant, do I only look at one of the two experiments, or do I consider both experiments? I want this one to change, but I want this one to remain constant. Do I only look at one experiment, or do I look at both experiments? One only. That's why, in order to find order with respect to AS2O3, am I using continuous method, or am I using initial rate method? Because it's only one experiment that you're looking at. It doesn't matter whether you're looking at experiment 1 or you're looking at experiment 2, you'll get the same conclusion one. But you just need to know that for this one, you only need to look at one experiment. Okay? Because you need this one to change, but you want this one to remain constant. Alright, so let's say if we use experiment number 2. So this is a concentration time graph, and does this look like a straight line or does it look like a curve? So if it is a curve, you can already eliminate what order already? 0. So it cannot be 0 order, it can only be between first or second. So in order to differentiate between first and second, what must you find? Half-life. So you just find half-life. Alright, so if you didn't do your working now. Tell me what is the half-life of experiment number 2. Tell me what is the reading. All this working has to be shown on your graph. So what is the half-life if you are looking at experiment number 2? Roughly how many seconds? Okay, 30, 40, 50, it doesn't matter. So can you prove that the half-life readings are relatively constant? Yes. What about those of you who chose experiment number 1 to look at? If it's experiment number 1, what will be your half-life reading? About 30 seconds. So regardless of whether you use experiment 1 or experiment 2, it will give you the same conclusion that the half-life reading is relatively constant. Alright? You just need to look at one experiment for the case of ES2O3. So let's look at the answer for this one first. Okay, so you need to show your working on the graph. So for the answer that you see on the screen, right, I'm actually using which experiment? I'm using experiment number 1. That's why it's about 30 seconds. But if you use experiment number 2, then your conclusion will just be 15 seconds. Okay, you just use one of the experiment can already. There is no need for you to use both experiments. So this one is continuous method. all these working and construction lines, all these things have to be shown in your diagram, otherwise you will not get a full credit. And I'm not going to show you this anymore because we already did this in one of the previous questions. If you didn't do this, it basically just means that you don't bother to learn. Okay, but basically this is the conclusion. There's no need for you to write both of them. You just need to write one of them can already, depending on whether you choose experiment number 1 or experiment number 2 to come to your conclusion. Okay, once you are done, I want you to look at the B part 2 now. So now I want to find the order with respect to CrO42 minus, which means that my CrO42 minus must change or must it remain constant. So this means that do you use one experiment or do you use both experiments? Both, because you need it to change. So since you are using more than one experiment, therefore this is solved using the initial rate method. So you need to be very clear what is the method that you are using to solve the question. Okay, now look here, I'll give you time to copy whatever that you need to copy later, so please pay attention. You must always remember that if you want to find the order with respect to something, that should be the only thing that is changing. So this means that this one must be the only thing that is changing. This one must remain what? Constant. There's only one point between these two experiments that is the same, that has the same AS2O3 reading. Where's the point? At t equals to 0 here. So this must be the only point that you can actually use to determine the order with respect to your CrO42 minus. So what can you do? This is a concentration time graph. If I draw a tangent and I find the gradient over here, what does the gradient give me? The rate of reaction. So this one will give me the rate of reaction for this experiment. Then you do the same thing, you draw a tangent for the other line at t equals to 0. You find the gradient, this will give you the rate of reaction for the other experiment instead. So you can find two rates really. So this one roughly is like this one. Then this one is like this. So the rate is obtained from the gradient. So once you get the two rates, you can now do the comparison now. What happens to the concentration of CrO42 minus when you go from here to here? Double. Then what happens to the rate of reaction? Double. Therefore, the order with respect to CrO42 minus is first order. So that's how you find the answer with respect to CrO42 minus. There are a few things that I want you to pay attention to. Can you look here? Number one, whenever you draw the tangent at t equals to 0 to find the gradient, in order to make your life easier, draw the tangent so that it intersects your y and x axis. The reason is because when you intersect both axes, it is easier for you to read the coordinates. Okay, for you to find the gradient. Number two, when you find the gradient, is the gradient a positive value or negative value? Negative. So you need to modulus it because rate cannot be a negative value. So these are the things that need to go into your working. Okay, first thing first, look at how I draw my tangent. I always draw my tangent so that it intersects my x and y axis. This will then allow me to read the coordinates more easily so that I can find the gradient more easily. It's not a must, but it makes your life easier. Okay? So make it a good practice to always intersect your x and y axis.
The question says the initial concentration of AS2.
0.58 is it? Then change it to 0.58 now. Yeah, actually I can tell you for questions that involve the drawing of tangent, your answer can vary quite a bit because it depends on how well you draw your tangent. So sometimes you need a little bit of cheating. For example, if this one the concentration times 2, right? The reading there should be roughly half as well. Okay, so if you adjust the intercept a little bit, then your reading will be nicer when you do the comparison. Okay? Otherwise, the reading can be a little bit off, depending on how well you draw your attention. Anyway, this is the conclusion. So this is how you show your working. You need to show how you calculate the rate of reaction for both of the experiments. So you can see that I take the modulus of both the gradient. Because gradient, tangent rate cannot be negative value. I think there should be a unit there for the rate of reaction. I don't know why I forgot to write down. Can you tell me what is the unit, since it is the gradient of your graph? Mole per dm cube per? Yeah, so actually it's better to write down the units as well. The unit should be mole per dm cube per second, because it is basically just the gradient of your graph, which is y over x. In this case, yes, because rate is defined as change in concentration per unit time, which is basically what the gradient gives us in this case. Yeah, so yes, in this case, yes. One more minute, then we will move on to the next part of the question. So in your exam, before you find the gradient, please write down the two coordinates that you are using to find the gradient. Otherwise, your marker don't even know how you found the gradient, where did you get the points from. Okay, so please write down the coordinates. Alright, let's move on. The rate equation basically is first order with respect to both reactants. So it's first order with respect to AS2O3. It's also first order with respect to CrO4 2-, as we have actually found out in the previous two parts of the question. Okay, this one is actually very important. It's not that easy, but I need you to pay attention over here. So before I look at the additional experiment, right, I want you to go back to this rate equation again, right? Can you please look at experiment number 2? Tell me what is the initial concentration of the CrO4 2- for experiment number 2. 6 mole per dm cube. Can you tell me what is the initial concentration of AS2O3 for experiment number 2? Now looking at the concentration, and if you compare the concentration, can you tell me something about this concentration compared to this concentration? Is present in large excess, which means that this concentration will remain Not constant, relatively constant during the course of the reaction. And that's why I can actually further simplify it to be like this. And that is why it is a pseudo first order reaction. Does this make sense? And that is why this graph over here shows constant half-life with respect to your As2O3, because it is a pseudo first order reaction. Now, what the question is doing now is they are trying to repeat the experiment. But now for the repeated experiment, can you tell me what is the concentration of the CrO4 2 minus? 0.59. This one, 0.58 is good. Now look at the concentration. Is this still present in large excess? So will this remain relatively constant during the entire reaction? No. So will you be able to simplify from this step to this step?
No.
So the reaction is no longer a pseudo first order reaction. Tell me what is the first difference between this original line and the new experiment, since it is no longer a pseudo first order reaction. The what is not constant anymore? Half-life is no longer a constant value because it's no longer a pseudo first order reaction. Secondly, you are decreasing the concentration. When you decrease the concentration, what happens to the rate of the reaction? Decreases. So what will happen to the gradient? It will be gentler. That is your second difference. Alright, so the first difference is that your half-life will no longer be constant because it's no longer a pseudo first order reaction. Second difference is that your gradient will become gentler because the concentration has now been lowered already. Actually, it's lowered by 10 times. So the gradient will actually become gentler by quite a significant extent. So this question is very important because it combines both the initial rate method and the continuous method into the same question, and it's a very common question that you will see once you start doing past year questions. Please make sure you know how to do this kind of questions. I don't know whether you will understand when you write that down, so please make sure you understand why originally the graph, the half-life was constant, but then the new experiment, the half-life is no longer constant. It's because the concentration that we are using. Initially, one of them is present in large excess, but for the new scenario, none of the reactants is present in large excess. So that is the key difference. So please make sure you are aware of this. Okay, we will pause for 1 minute. If there's anything you want to clarify up to this point, you better clarify. Because after this, we are going to move on to the second part of the topic already. We are done with all the orders of reaction questions. Okay, let's move on. Alright, so the second part of the chapter is on reaction mechanism. There's only 3 important learning points that I want you to take away. So every time I reach a learning point, I will tell you that is the learning point, and I want you to write it down. Okay? First thing first, we need to know what is the meaning of reaction mechanism. Okay, so on the left hand side, what you see is a chemical equation. On the right hand side, what you see is a reaction mechanism. What is the difference? The difference is that your chemical equation tells you the overall relationship between the reactants and the products. But for a mechanism, it tells you step by step how does the reaction take place. Alright? So that is the first important learning point. You need to know that for a chemical equation, all it tells you is the overall relationship between the reactants and the products. But for a reaction mechanism, it actually tells you step by step how a reaction actually takes place. So this is the first thing I want you to know about the difference between a chemical equation and a reaction mechanism. Right, can anyone tell me, right, if I sum up all the steps in the reaction mechanism, what will I get? Get the overall equation. Okay? So this must always be satisfied for a reaction mechanism one. Whenever you sum up all the steps in the reaction mechanism, it will always give you back the overall chemical equation. Okay, so this must always be fulfilled. Okay, now comes to the second important point. Please pay attention over here. So if you remember, previously I mentioned to you, if you want to establish the rate equation, to get the orders of reaction right, you cannot simply just look at the coefficients of the chemical equation. Can anyone remember why? How come in order to get the orders of reaction, you cannot simply just compare it with the coefficient of the overall chemical equation? What is the only way to get the orders of reaction? Using experimental data. So that's why that is wrong. Okay? You cannot just say that the orders of reaction are just the coefficient of the overall equation. You must make use of experimental data. However, a reaction mechanism is obtained using experimental data. Therefore, the coefficient of one of the steps actually coincides with the orders of reaction, and that is called the rate determining step. So for example, if your first step is your rate determining step, can you tell me how many A are there in the slow step? 1. And how many B are there in the slow step? So therefore, your rate equation will look like this. Okay, so the second important learning point is the orders of reaction is not equal to the coefficient of the chemical equation, but the orders of reaction are equal to the coefficient of the rate determining step of the mechanism. That is the second important learning point. And you need to understand that the reason is because reaction mechanism is obtained using experimental data. Okay? So this is the second important learning point. The orders of reaction is equal to the coefficient of the slow step in a reaction mechanism. Okay, now comes the third and final thing that I want you to remember about mechanism. Currently, my slow step is the first step. What happens if I change the slow step to the second step? Can you tell me how will your rate equation look like if your slow step is your second step? First order with respect to what? A, and first order with respect to what?
AB.
Now can you tell me what is wrong with this rate equation?
AB is not
Rate equation can only be written in terms of
reactant.
reactants, but AB is not a reactant, AB is an intermediate. So for such a scenario, you need to think of a way to get rid of the AB. And actually this part is actually related to the next topic, which is on chemical equilibrium. In order to get rid of the AB, you need to look at the previous step. Okay, and you need to know that for every chemical reaction, right, the products and the reactants are related by a constant like this. It's always products over reactants based on the coefficient. So this is product, coefficient is 1, over reactant, over 1. Okay, so this one, after you learn the next topic, you will know that the products and the reactants are always related by a particular coefficient like this. Alright, so from this one, you can actually see that your AB is equals to K times A power 1, B power 1. Then now you can actually sub your AB into that expression over there, just mathematics. Is this correct? You just math on it. You're just substituting AB as that. Is this correct? Sorry? No, up to this point, is it mathematically correct? Yes, I haven't simplified it. Okay, so this will be your final rate equation. So you need to get rid of any intermediate that you actually see in the rate equation, because rate equation can only be expressed in terms of reactants only. Of course, this one you can actually simplify it to K prime, because it's just a constant multiplied by another constant. Okay, so this is the last learning point that I want you to remember. Actually, we mentioned this in the first summary already. Rate equation can only be expressed in terms of reactants and catalysts only. It cannot be expressed in terms of intermediates or products. Okay, once you are done, please go back to your tutorial question. Let's look at question number 7 now. Anyway, this one I've done it on the screen already, I mean on the whiteboard. Okay, we're going to do some practice using what I have shown you on the board there. Let me ask you for the answer first, because the answer is actually quite simple for question number 7. Okay, first of all, can you just tell me the answer very quickly, because the answer should be pretty straightforward. A is the answer, right? But what I want you to do now is, can you find me what is the correct rate equation for B, C, and D? Do it now. A is the answer, that one is the obvious one. I think B is so simple, it's the C and D which is difficult. So can you do the mathematics to find out what should have been the rate equation for option C and option D using the math involved? That was a past year A-level question, so you need to know how to do it, how to get rid of the intermediate. Okay, by writing a constant for the previous step. So the constant is always products over reactants raised to the powers of the coefficient. Maybe 2 minutes, you shouldn't be taking longer than that. It's just mathematics only. Part D, can you assume that water remains constant? Because usually for reactions that involve water, water is usually used in large excess. Right? So for option D, can you just assume that water is relatively constant, so you can put it as part of the constant? Okay, most of the time, question that involves water, water is used in large excess. Right? Most of the time. Okay, so for part D, can you just assume that water is used in large excess? So you just put it as part of the constant. Okay, I think most of you are done already. Can you check your answers now? A and B no need. I think A and B is pretty straightforward. So let me just scroll down for you to take a look at C and D. Yeah, so this was C and D. If you got it wrong, you might just want to take a picture so that we can actually move on. If there's anything wrong, you better let me know. Is there anything wrong? That should be HBR power 1, is it? Sorry?
Why? Oh, yeah.
Alright. Then only HBR times HBR is HBR square. Yeah, okay, thanks. Okay, then for those of you who didn't know how to do question 8 part A, now you should know how to do really. Because question 8 part A is also using this method 1. I'll give you 1 minute solve for 8 part A now. Because you cannot leave your rate equation in terms of an intermediate. You must get rid of the intermediate. Otherwise, your answer is wrong already. So look at your rate equation for 8A. If it has an intermediate, please get rid of the intermediate. Otherwise, your answer is wrong. So you're telling me that 8A you still don't know how to do? So you don't know how to do all this? I'm asking you a question. Do you know how to do all this? Then what were you doing for the past 5 minutes? Sure lah, what is sitting there? Obviously she's wasting her time in class, right? Anyway, let's not waste our time. Okay, let's look at the answer here. Shouldn't be a problem. Okay, next one we're going to learn how to draw energy profile diagram. Energy profile diagram means you are going to show how the energy changes as the reaction progresses. So can you tell me what is the y-axis first? Energy. And what is the x-axis? Sorry? Progress and reaction. Alright, now let's do it one by one. First of all, you need to know how many humps are there in the reaction profile diagram. That will be actually given by the number of steps in the mechanism. So how many steps are there in the mechanism? So that means there will be 2 humps. How do you draw the humps? You need to look at, first of all, which one is the slow step and which one is the fast step. So you can see that step 2 is the slow step, right? Slow step means the activation energy needs to be higher. That means your second step, the activation energy needs to be higher. Finally, you also need to be considering the enthalpy change. For the first step, the enthalpy change is positive or negative? Positive. So this is how you draw it. So the first step, the enthalpy change is a positive value. For the second step, the enthalpy change is positive or negative? Negative. And the activation energy is higher or lower than the first step? Higher, because it's the slow step. Okay, so your graph will look something like this. So this is how you draw it. So this is your delta H for the first step. This will be plus 3 and 4. And then your second step will be like this. This is delta H2 minus 611. Okay, then not only that, you also need to label your activation energy. This is your first activation energy. Did they give you or they didn't give you? Doesn't matter. And then this one is your second activation energy. EA2. Okay, finally, for reaction profile diagram, right, you also need to write down all the reactants and the products. Let me finish this first, then after that, you can copy whatever that you need to copy. You don't need to draw out the shape of the molecule. Just tell me, what is the reactant over here? How many I know? 2 I know. Stay simple? Yes. Okay, then what is present as the intermediate here? Stay simple? Yes. Tell me what is present in the product here? 2? Okay, wait. We'll do it step by step. So there's 2 NOBR here, right? So you can see that the steps, the atoms are not balanced. So you need to go back to make sure that every single step is balanced. So can you tell me what else do you have to have as the reactant in the second step? Last one? BR2. But if you have BR2 over here, you also need to have BR2 over here. Otherwise, the atoms will not be balanced. So even though your BR2 is not involved in the first step, you still need to include it. Otherwise, the atoms will not be balanced between the steps. So this is how you actually draw the entire reaction profile diagram. Okay? So this is something that you need to pay attention to. Even if something is not used in a particular step, you need to make sure that every single step the atoms are balanced. Okay, so the BR2 has to be included in these two positions as well. Otherwise, the number of atoms will not be balanced. Okay, so please check that you have everything. Yes, of course, because you need to show that the second step is the slow step and the first step is the fast step. Okay, so you need to label that EA2 is larger than EA1. Is the answer this one? Yes or no? Put your tutorial answers in my locker. But I have to be. Is that clear? What? From what we didn't complete today until the end of the tutorial. After this, let's see. What happened to you after that? Okay, once you're done, can you please look at question number 9? Right, what C? Oh, okay. We need the sign of entropy change for the overall reaction. Okay, let's come back to this one now. So you are supposed to predict the delta S sign for this overall reaction, right? So which one of the 4 factors should we be using? Number of gaseous particles, because there is a chemical reaction. So is there an increase or decrease in the number of gaseous particles? So you expect the delta S to be positive or negative? There's an increase in the number, there's a decrease in the number of gaseous particles. So delta S will be negative. Okay, so that was the last part. we may not be able to finish the entire question 9, but it doesn't matter, we'll do what we can. Can you please look at question number 9 now? So this is what the question actually tells us. They say that propanone reacts with iodine to form hydrogen iodide and the other product over there. So the question is actually very kind. They already tell you the orders with respect to the different things really. Can you tell me what is the first thing that they tell you the order? Order with respect to? I2. So it is independent of I2, so the order with respect to I2 is 0. Directly proportional to H plus. Finally, the question also tells you that it is directly proportional to the propanone, which is again first order. Interestingly, you don't see H plus in this equation at all. And this is telling you that the H plus is behaving as a what for this reaction? It's a catalyst. Because rate equation can only be written in terms of reactants or catalysts. So if you don't see the H plus in the balance equation, it is basically telling you that the H plus must be behaving as the catalyst. Alright, so that is the catalyst for this reaction. So what is the overall order of this rate equation? 2, right? Okay, then how to find the units of the rate constant? We actually did it in one of the previous questions, but I'm just going to do it one more time, once again. Tell me what is the unit of rate? Mole per liter cube. You don't know whether it's per second, but never mind. In this case, you can just assume. And this one is the unit of the rate constant. There's 2 concentration terms over here. Each one of them, what is the unit? Mole per liter cube. Power 2. Then after that, you just need to do your math to find out what is the unit of the rate constant. Okay, tell me the overall unit for the rate constant. Okay, quickly. Mole minus 1. Okay, so that's the overall unit for the rate constant for a second order reactor. Over there, I write per unit time because the question never gives us the unit of time. But it doesn't matter, if you write per second, they also cannot knock you wrong because they never give you the unit of time. Okay, let's just revise what we said at the beginning of the tutorial. I mentioned to you that the rate equation can be obtained using which step of the mechanism? The slow step, right? So, in other words, by looking at the rate equation, it also tells you what is present in the slow step of the mechanism. So this is telling you that in the slow step of the mechanism, how many H plus must there be? 1. And how many propanone must there be? 1. So now you can tell me already, which one of the 2 mechanisms shown on the screen satisfy this rate equation? Okay, that's how you get the answer. So the rate equation and the slow step of the mechanism must always fit together. Right? Okay? So that is one of the important learning points that we actually talked about. Your rate equation and the slow step of the mechanism must always fit with one another.
For the chemical equation, right? Like, how do we know there's an HI?
How do I know what?
How do we know there's an HI?
By balancing the number of atoms on the left hand side and the right hand side, you will see that the only difference is 1 H and 1 I. Yeah, so this one is just by balancing atoms only. Yeah, so you total up the carbon, oxygen, hydrogen, iodine versus this one, the only difference is 1 H and 1 I. So this one must be your byproduct. Anyway, let's just finish this very quickly. The last few parts are all very quick one. H plus, you have already told me really what is the purpose of H plus in this reaction over here. But you must define what is a catalyst. A catalyst provides an alternative pathway of lower activation energy. Next, what is the function of I2? We cannot just say reactant. You must describe what kind of reactant is it. So in order to do so, let's find the oxidation state. This one is 0. What's the oxidation state of iodine here or here? -1. So what is the iodine undergoing? So what is it behaving as? So that's the function of the I2. The I2 is behaving as an oxidizing agent for this reaction. Okay, reactants is too generic really. You must explain more in depth. Okay, what kind of reactant is it behaving as? Next one is a trick question. So they are asking you, right, if they change the iodine to bromine, how will the rate of reaction be affected? In order to answer this question, you need to know, in a mechanism, which is the step of the mechanism that determines the speed of reaction? Now go back to your mechanism A. Tell me what is present in the slow step of mechanism A. Propanone and which one? Do you see the halogen in the slow step? So this means that if you change the halogen from I2 to Br2, what will happen to the rate of reaction? It doesn't change because the halogen is not even in the slow step of the mechanism. So therefore, the rate of reaction does not change. So this part is just telling you that you need to be very careful. In order for something to be able to affect the rate of reaction, it must be in the slow step. If it's not in the slow step, changing it will not affect the rate of reaction. Okay, and after this, one more part, then we are done for today. Okay, let's finish up on this one. This is the last part of the question really. So the question says that oxides of nitrogen catalyze the oxidation of SO2 to SO3. SO2 to SO3. Tell me what are the oxides of nitrogen you are familiar with? There are only two of them only. NO2 and NO. So let's say the oxidation is catalyzed by NO2. So this one have to donate one of the oxygen over here, that's why it becomes SO3. After donating one of the oxygen, it will become what? In order to call this a catalyst, right, at the end of the day, it must be regenerated. So currently it's like this. In order for this to be regenerated, what will it be able to react with in the atmosphere? Oxygen. So it's like this. So it's regenerated, that's why it's behaving as a catalyst. And for catalysts, there are many different types of catalysts. Homogeneous, heterogeneous, a biological catalyst, autocatalyst. What kind of catalyst is this? It's homogeneous because everything is taking place in the, that's why it's a homogeneous catalyst. Everything is happening in the gas. Okay, so we will stop here today. Then tomorrow we should be able to finish the rest of the tutorial already. Wednesday we will see how it goes because I still don't know. Huh?
It doesn't affect us.
Don't know yet, man. Net bombs got.
Wednesday is 3:45.
So it doesn't affect you then?
Yeah.
Okay, so we will see how it goes. Anyway, we'll stop here today. The student counselors, you can get the video recording from Priya. She recorded the front part of the tutorial. So we are done already. You need to go for your quick break before the next lesson. Please go quickly before you come back.
Yours literally.
Pretty.
Yes. Good job.
I'm so proud of you.
Oh, and also Seth. Better win.
Yeah.
You better win. Okay, bye.